right, good afternoon, everyone. I hope you all had a great weekend. So before we jump into the chapter 8 today, I want to go over a couple things. So first of all, there's no homework this week. Figure you had the exam, you've got the exam corrections. Probably enough work for 1 week. So not going to beat you up with any homework on top of that. But then apart from that, I wanted to go over the exam briefly. Basically, I'm just going to go through each of the questions. If you have any questions after I go over all of them, I'm happy to readdress anything if I need to. But for now, I'm just going to go ahead and run through these. So this first question here is asking, why is it not giving you the table in a format where you have your different departments and the employees inside of each department? So the reason is because you don't have a group by statement. So if you had a group by statement, you would actually see your output would be grouped like this. So each of the departments, because that's what we would set the actual group by condition to, for each unique instance of that. So in this case, I didn't actually set any actual data. Let's just say we have 5 different departments. We're going to have 5 unique department numbers, assuming that's what we group by. And then from there, it's going to allow us to count the employees in the department, because what we're doing is we're counting the department number inside of the employee table. So if an employee is inside of one and only one department, which the business rules specify according to the ERD, all we have to really do here is just add in a group by statement. So if you said something about group by missing, or you gave a potential group by statement, you got credit. If you did not, well, you did not. So this next question here, write a query to output everything in the employee table. All you have to do there is just do select star, that's our wildcard, from employee, semicolon. So on this third question here, which entity is an associative entity in the ERD? So of course, all the questions reference the ERD for the handout. So in this case, you look at the handout and you see which one is an associative entity. In this case, it's going to be department position down here. So you would just select department position. You'd be in a good spot. Then write a query to output the columns from the department table in the following order: department name, location, department num. So I was kind of nice on this question here to match the variable names of what I ask in the question. So basically, all you have to do there is just do select department name, comma, location, comma, department num from department, semicolon. If you did that, you're in a good spot. So for this next question, it's a little bit trickier, but still not too bad. Write a query to output all the columns in the employee and department tables. Give a little hint here just to kind of make it pretty clear as to what I was asking for. I'm basically asking you to do a join statement here. So you would just do select star from employee, join department on employee dot department num equals department dot department num. Put a semicolon at the end, you'd be good to go. All right, so here is a question that says, write a query to output the employee first name, employee last name, emp ID, and salary, amount of all employees who earn over 100,000 per year. So again, all you have to do here is just say select, let's see, F name, comma, L name, comma, emp ID, comma, salary from employee where salary greater than 100,000, semicolon. So that's really all you have to do there. And then this question is asking, why won't the below query run in MySQL? So the reason is because MySQL doesn't recognize the intersect operator. So instead of using intersect, you would use AND_EXIST for duplicate functionality. So if you said that MySQL doesn't recognize intersect, you got credit. Some interesting answers on this one. But again, the key here is that why doesn't it run in MySQL? So different SQL implementations have slightly different syntax, not drastically different. But I'll give you another example. If you wanted to do select into instead of MySQL, you have to go in a quite a bit more complicated way than you would in any other implementation that I'm familiar with of SQL. So there can be some slight differences, and that's certainly something that we covered. So make sure that That makes sense. Then why would a business want to use a view in SQL? Most people got this. Basically, a view allows you to not have to retype the same information over and over. Say you wanted to have a report that you generated. You're very interested in doing certain joins, but you don't want to type them all out all the time. Basically, the main idea there. Okay, and then for this one, write a query to output the average salary for all employees. All you'd have to do is just do select AVG, open parentheses, salary, close parentheses, from employee, semicolon. Okay, and for this final question here, it says write a query to return the first and last name of the highest paid employee. So a fair bit of people miss this one, and I guess it could be a little bit trickier. So the key here is you had to use a nested select statement, because inside of the where condition, you can't use those functions like max, or not max. You can't use max, you can't use average, you can't use count. You have to do those inside the select function, or the select statement rather. So inside of here, what you would do is you would do select fname, comma lname from employee, where salary you could either do greater than equals to or equals to, and then you do open parentheses select max salary. Of course, you put the salary there inside of parentheses as well, from employee, close parentheses, semicolon. So that's how you would do that. You just make sure that you do a nested statement here. Any questions about any of these? Again, I didn't give a whole lot of feedback on this, but basically, let's go ahead and talk about why. So I did give the opportunity to do exam 2 corrections. So I accidentally posted exam 1 corrections here earlier. I went ahead and changed it, but I don't think it would let you submit them anyway. So basically, I'm giving you the opportunity to earn half credit on what you missed. So, I use the example, if you got an 80 on the exam, you missed 2 questions. I went ahead and gave you 10 points for a curve, so you'd be up to a 90. And then on top of that, let's say that you submit exam corrections for the 2 that you missed following these guidelines here, then you could earn an additional 10 points. So you add 10 to 90, you'd be at 100 even if you missed 2 questions. Let's say you get a 60, again, you can make up to a 90 because you'd be able to get an additional 20 questions on top of the 10-point curve, or additional 20 points rather, not 20 questions. But yeah, so that's basically what there is to do here. Make sure that you read it if you're going to do it. It's completely optional. I'm not sure why you wouldn't do it, but if you don't want to, that's no problem. These are due Friday, so 2 days from today. So they're due in 2 days. So midnight. If you accept them late, I won't accept them. In fact, I don't even think you'll be able to submit them late. So make sure that you submit, even if you don't finish. Submit, say, I don't know, 3 out of 4. That's better than submitting 0 out of 4. So certainly keep that in mind. Yeah, any questions about anything before we jump into the content for today? Any of the test questions unclear still? Any questions about the exam 2 corrections? Again, I'm always happy to answer any questions. So certainly feel free to, if you think of anything, to let me know. All right, so today we're going to be talking about normalization. And normalization is kind of like what we've done before with the ERD. In the ERD, you think about, we do iterations of it. Why do we do those iterations? Why don't we just stick with the initial thing inside of whatever we first come up with? Why is that not always the best answer? Is it the best answer? What do you guys think? And why not? It's all right. So the quote here says, "There are many paths to the top of the mountain, but the view is always the same." Now, a lot of times the quotes on here, I don't always understand what they're, but in this case, it makes a lot of sense. So, we can take this normalization approach we're going to talk about today, and we can get to the same data model as if we take the ERD approach. So you have some flexibility there. There's also an entity relationship approach we could take, not to be confused with the entity relationship diagram. It's just a less structured version of it. Whatever we do, if we're following the best practices, we're following what makes a good data model, we'll end up with a high fidelity data model, no matter which approach we take. So with that in mind, let's talk about normalization. So as I kind of said, this is kind of contrasting with the ERD that we've done. I think ERD is a pretty simple tool to understand. Normalization, I'm not going to say it's not a simple tool, but it's certainly more complicated. So, as we go throughout this, don't get too bogged down in the specifics. Think about how you go from one form to the next form. It's almost always the same thing. You break it down. So we'll talk about that. But basically, this is what enables the ERD approach. So when we have that relational model, we can do it because of the normalization approach. We're actually using the same concepts. We're just not thinking about them in the same terms. So that's really what we're doing today. And it's important to note about functional dependencies. So what a functional dependency is it's saying one thing determines another thing. So if we put this in terms of a database, we have one attribute inside of a table. And that attribute can determine what another attribute is inside of the table. So the example here is a stock code tells us a lot of things. We think about what's the ticker of a company. Well, it could be something unique to that firm. Because it is unique to that firm, it tells us lots of information. It tells us the firm name, tells us where the firm is headquartered, tells us what their stock price is, all sorts of different things because we have an identifier. So really, all this is just a candidate key. It's something that could be a key. Now you may say, well, why is this important? Well, because to distinguish between the different forms, this is one of the things we look at. And then, of course, we can also have, certainly multi-valued dependencies. So instead of just using one single attribute to determine something, we can use a combination or some calculation of attributes. So in this case, we take stock dividend, stock price, and that's going to give us the yield. So that's going to be a ratio. We divide the stock dividend by the stock price. It tells us what percentage we're getting back in terms of a dividend, at least. So that's certainly something that we could determine. But we can't do that with a single attribute. So then we have the idea of having full functional dependency. And basically, this is saying that we can't determine the other thing at all without having the information. So that's really all there is to this. It's saying, can we determine yield without having stock dividend or stock price? We cannot. We have to have both of them to determine what the stock price is, or what the yield is, rather. So certainly, that's going to be a case of full dependency, where we cannot determine what the value is without having these determinants. So that's basically all we're talking about here. But it's not always the case where A is going to only give one value of B. So we think about this in simple terms. Imagine we had a list of country codes. Well, if we have the abbreviation USA, what country is that? Yeah, exactly. So that's certainly something that's going to be a single determination. It determines that. But imagine we're asking about currency. So I was given, let's say a country over in Europe. A lot of them use the euro. So if I give you a country, you can probably tell me what, what currency uses it, but you can't necessarily tell me if I give you the currency, which country uses it. So certainly keep that in mind. If I gave you the euro, can you tell me which country specifically uses it? No, because there's multiple. That's what we're talking about with multi-determination. So the example here is that department has multiple courses. So it's the same thing with the euro example. Euro has multiple countries. And basically, we can kind of multi-determinant, but we can't do it on a one-to-one basis. So that's all we're talking about here. So kind of backing up a little bit, we talk about the one-to-one relationship. Well, if we're talking about this in terms of the multi-determination, means that A only corresponds to B, and B directly corresponds to A. So in this case, CH, I'm assuming that's the abbreviation for Switzerland, determines Switzerland, and Switzerland determines the abbreviation CH. So it's certainly something that we're doing here, where we're taking one thing and we're determining another. Think about this in terms of a student. Your student ID determines your name. Your student ID is unique, and your name is probably unique. Of course, we're going by full name here, not just your first name or just your last name. But certainly, if we use your first, middle, and last name, that's probably going to be pretty unique. Not necessarily, but in most cases, it will be. So that's certainly going to be an example of a one-to-one. Any questions so far? Let's get a little bit more complicated here, but not too much more. So now we're going to talk about the one-to-many. So basically, all we're saying here is that we can go one direction. If we have the country name, we can tell which currency they use. You know, there's not a country that uses multiple currencies. Well, there probably is, but we're going to assume there's not. So when we assume there's not, we can do this. So, however, the problem is multiple countries use the same currency. So given the currency unit, we can't tell which specific country we're talking about. So, of course, looking back to the ERD, this is a one-to-many relationship, where on one side we can determine rather what the outcome will be, but on the outcome we can't determine what the determinant was. So that's all we're talking about. Then, of course, if we have a many-to-many, basically saying we don't know. You know, on both sides, we can't determine A given B, nor can we determine B given A. So, you know, here's a good example here. If we have a country name, we can't determine which language they speak. Languages can speak, our countries rather can speak multiple languages. Think about a nation like Canada. You know, which language does Canada speak? Do they speak French or do they speak English? Exactly. So, you know, certain provinces have different provincial rules, but when we're talking about the grander scope, you know, we're going to assume that, you know, we can't determine it. And if I give you a language, you know, in most cases, you can't tell which country that is. The language of English. A bunch of countries speak English. If I give you the language of Spanish, a bunch of countries speak Spanish. You know, so certainly that's an example of a many-to-many. We cannot uniquely identify each instance of that relationship. So that's what we're kind of talking about here. A little bit confusing, but not too bad so far. So now we're going to put this in, you know, kind of explain why we spent so much time talking about determinants. Because normal forms, you uniquely identify them by which level of determinants you have. So certainly that's something you want to consider. The book is an example of they're stacked like a set of Russian dolls. Anyone ever seen Russian dolls before? You know, you start taking them out, there's more and more. You know, certainly going to be a pretty large amount of Russian dolls inside of a Russian doll. So, you know, we get to the first normal form. That's going to be the one that's in the very, very center, smallest one. You know, I don't know that that's going to help you make any sense of it, but certainly that's kind of the analogy here. So when we're at first normal form, what we've done is we've taken a table and we've ensured that each and every row inside of the table has the same amount of columns. Now, this doesn't necessarily imply that there are no null values, but it's saying we're not having a case where only certain things have, or only certain records have certain columns associated with them. So this isn't necessarily what we consider to be well-formed at this stage. It's certainly not considered high fidelity, but at a minimum, we only have single-valued attributes. So let me ask you guys this. If I had a table and it had address inside of it, and the address had, you know, your street number, you know, your zip code, state, all that inside of it, is that first normal form? So that would not be a single valued attribute. So we wouldn't actually be inside a first form at that point. Now let me ask another question. Imagine if I had a table and it was a schedule table. And I had, the student information, and then I had course 1, course 2, course 3, course 4, course 5, course 6. Is that in first normal form? So that's not in first normal form either, because all rows must have the same number of columns. Not everyone's taking 6 courses. So you'd have quite a few null values. You can have a few, but you can't have that many. So, that's not going to be kind of at that level we want to be at. So how do we get from that approach to first normal form? Well, let's start with the example of address. If I have a multi-valued address, how do I make it a single valued address? So I'd break it up. So instead of having address, I would go ahead and pull out the street number. I would pull out the street name, pull out the zip code. If there's a second address, like, apartment number or something, I'd pull that out as well. City, state. All that information would be stored inside of separate attributes. That allows them to be single valued. So we only want to have single valued attributes. Now you could certainly throw the example of me at, well, not everyone has an apartment number, so the second address field may not make it first normal form. Well, in that case, it's certainly, that's a logical argument, but that is generally thought of to be first normal form. So just kind of keep that in mind. Having something like that is okay, but having something where you have like course 1 through course N, that's not okay. Well, it's not necessarily not okay, but it's not in first normal form. So, and again, if we had the case where we had those courses all inside of a single table, instead of doing that, what can we do? Exactly, have a registration table. And the registration table would have which term this is for, which student this is for, and it would have, which course it's for. So, multiple students, students are going to have multiple registration entities, likely, or not multiple registration entities, multiple registration instances. So that's how we get from it. Basically, when in doubt, break it down. So now let's talk about second normal form. So this is what we're saying where we have, a non-key column is part of the fact about the primary key. So let's just look at this and talk about it. So the primary key is a composite key comprised of item number and customer ID for the order. Now, the problem is that customer credit is only determined by customer ID, and it's not determined by the combination of item number and customer ID. In other words, it doesn't matter if a customer purchases item number 1 or item number 27, they're going to have the same customer credit. So how can we solve this? If we wanted to get this to second normal form, right now this is first normal form. We want to get this to second normal form. What do we do? So we don't have to have the customer credit inside of the order table. We can instead put the customer credit inside the customer table because the customer credit is related to the customer and not the order. So that's going to be the best approach, is to break it down and to move things to whatever they're going to be directly corresponding with. So we certainly would not need to have this information. Also think about it like this. If you had multiple orders, do you need to have your credit score, or whatever this is, do you need to have that repeated as many orders as you have, or could you have it one time? Exactly. So certainly, you want to minimize redundancy. So think about it like this. If whatever you're having inside your table doesn't relate to the table, put it somewhere else. Put it somewhere where you can reduce redundancy. You can think about this a lot of different ways. Don't get so caught up in the exact wording here. But basically, what we want to do is we want to make sure that in this case, we kind of think about this. There's a saying. You guys have heard the nothing but the truth, the whole truth, and let's see, how does that go again? The whole truth, nothing but the truth, and well, I don't remember. But in the terms of a database, we have a similar saying, and what we're doing is we're starting at the first normal form. We have the whole truth. everything inside of the database is there. And then we go to second normal form. We have, that's going to bug me. I don't remember what the saying is. We'll come back to that. That'll be an end of the class activity. Certainly feel free to look up what that is, you know, whenever they swear you in for testimony. It's the same thing, though. So that's what we're doing here. And then we have third normal form. And basically, third normal form is saying that whenever we have a non-key column is a fact about another non-key column, that's going to be an issue. So in this case, we have exchange rate is related to nation. So we wouldn't want to have that case because we have a candidate key of nation. Nation is unique. So we can't have that inside of third normal form. It's okay inside of second normal form because second normal form is concerned with the key unique, not fully recognizing what's going on. But inside of this, we have the nation. That's a candidate key. So basically what we're saying is third normal form, we're not going to have candidate keys that can uniquely identify other attributes inside the table. So if it's going to do that, we're going to have a separate table. So to kind of solve this problem, we'd break it down again. We'd have a nation table. So right now, we have stock code, and we have nation and exchange rate. So our stock code has information about the nation. But we don't need to have information about the nation and the exchange rate because the exchange rate is directly tied to the nation. So to kind of solve this, we would just make a nation table and put the exchange rate inside the nation table. Because that way, we're not repeating the information. If we have a billion stocks from USA, we're not repeating the information a billion times. We're only repeating it once. So we would instead have one foreign key that's going to correspond to the nation table and allow us to access all the stuff using join statements. So is this kind of making sense to everyone so far? All right. Now, I'm going to go ahead and skip voice code normal form. I'm also going to skip fourth normal form, as well as fifth normal form. Certainly not going to have any test questions about them. They get pretty complicated. There's not a whole lot of difference between third normal form and those additional forms. Certainly in practice, you're unlikely to ever be using this in terms of, setting something up in fifth normal form. Just not very commonly used. First through third, very commonly used. The additional three, not so much. So I'm not going to cover them. So inside of this domain key normal form, it's pretty similar to what we just talked about with third normal form as well. Basically, we have a unique identifier. It's going to uniquely identify each instance of the relationship. Then we have constraints specified. This is really the only difference. So this is an important difference, though, because what we're doing is we're saying, what constraints are we going to apply to this model? So then we're also going to have the domain specified. We're just basically making sure that we have the variable types, data types rather. So that's basically all we're doing here. The constraints are the important thing. They're going to determine what are the rules for governing these values. Do they have to reference something else? Do they not reference something else? We're going to specify that in domain key normal form. All right. So now we're going to talk a little bit about data modeling. So we've talked about data modeling before, and we want to make sure that our data model represents our data, that it doesn't have redundancy, that it's attractive, easy to read, that it's logical, makes sense, it follows business rules, which are going to be established by the firm, of course. And there's multiple different ways we can get to that approach. So, we're going to do some examples. I think Monday, because I think Friday are presentations. But at this stage, it's kind of difficult to determine which is easier to do. Is it easier to start with an ERD and to get it to a normalized state from there, or is it easier to use the first or third normal form? Now, again, I'm not going to ask any questions about fifth, fourth, or voice cod because they don't really add any additional information that we can't get other ways. So certainly we want to keep that in mind. The goal here is the same. This is a different approach to get to the same goal. So on the project, when we talk about that in a couple classes, you're going to be doing both approaches. You're going to be doing 1 through 3 normal form. You're also going to be doing an ERD. So you're going to kind of see both of those. You're going to compare, and you're going to see which do you prefer. They're just different ways. Some people prefer one way, some people prefer another. It'll be an interesting learning exercise to see. Then, of course, we're going to talk about the ER approach. This is certainly one I'm not going to have you do. You'll see why in a little bit. Basically, this is kind of a precursor to an entity relationship diagram. Entity relationship diagrams are very nice. They have the entity defined. Below that, they have the attributes for them. You put the primary keys up top, label the primary keys. Very clean. In this case, we're not really doing it that way. We don't have any specific standards for appearance. So whatever you see could be very different from another ER diagram. So here's an example of one right here. Basically, the rectangles are your attributes. The rectangles are the entities. And the ellipses are the attributes. So is this an easy diagram to read? Not really. It's pretty difficult to tell what's going on here. I think the ERD is a much better, certainly a much cleaner diagram than this. So again, I'm not going to have you ever do a question on the exam, project, or homework that relate to an ER diagram, but you could see one of these. So if you do see one of these, it could make a lot of sense to go ahead and put this into an ERD so it's more readable. You don't have to, of course. It's certainly an option that you have. So in this case, we basically just have three entities: stock, stock exchange, and nation. So, what we have here is we have some various relationships here, many to one, into many, lots of different approaches here. But we could definitely simplify this by using an ERD. So, kind of the way that we go about this, not so important. Just kind of emphasize, I've said this several times, but the main thing is that we get a model that makes sense. So if we do that, we're in a good spot. And again, there's no one way to get there. We can certainly use the normal form approach. We can go through that. We could go through making iterations of ERDs, determining what are problems, how can we make this better, and go from there. So there's no one approach. But just kind of wrap things up for today, normalization is certainly one valid way that we can do this. So it's not the only way, but it is certainly a way. And within inside of this, we can certainly represent this according to the normal forms. So we'll see some examples of that on Monday, where I'll have some various examples. We'll go through it together as a class and just kind of show it. But keep in mind, this is not going to be something where you're going to immediately pick up on it. So I think that having had the ERDs, you should have some intuition, but you may not get it right the first time, and that's okay. So certainly, you will see some examples of this on the exam, and by that point, hopefully you do get it right. But just kind of learning, it's not necessarily going to be perfect the first time. We'll go through all that. Any questions? All right, well, I hope you all have a great day. I will see you all Friday.